So today I'm going to review this UT1282A multimeter from Keysight. This has been sent to me at no cost by Keysight via Daniel Bogdanoff. You may have heard that name. He's the face of Keysight on their YouTube channel. I'll chuck some links down below as well, because Daniel's got a Twitter account and he's got his own YouTube channel. He started recently as well, so I suggest you go and check those links out and go and maybe subscribe to him. So let's get this thing out. Now I already opened this up in my mailbag video when this thing arrived. Had a little bit of a look at it, not a huge look. Haven't done much with it yet. Basically put some batteries in it, turned it on, did some basic checks. In here we've got the calibration verification, like, you know, confirmation of calibration. Keysight's website allows you to download your full calibration information and even history as well. Like if you send things to Keysight to get calibrated, they keep a record of that and you can actually download that off the website. So I actually went to the website and I actually found the calibration data, the factory cal data for this unit, and it tells me what all the calibration values were, you know, the actual measured values that this thing reported when it did a calibration, which is really interesting. So I've actually printed that out, so I've got it in here. So maybe we'll look at that. So you also get a set of probes. These are PVC, but it's quite a soft PVC, it's quite a good plasticized one. So that's actually pretty good. It's actually got some tags on it saying Keysight though. CCR, Keysight. What CCR is? Curious. Seems they're the ones that came with it, we should probably use them. And we've also got a computer interface. So it's an infrared like link which plugs into the back of the meter, and you also plug that into USB and you use PC software. I think it's on Linux as well, I'm not sure, but there's definitely PC software so you can communicate with and use Keysight software to actually talk to the unit and control it. I don't have a PC on hand, so I can't test this part of it, unfortunately. In time I probably will. I do have a laptop I can access, it's just not convenient. Maybe I'll do something in the future with that. So, test leads, let's have a look at these. I don't know, these are very flexible. Maybe they are silicon. I don't know, I'm scratching a fingernail, so probably not. No, these are PVC. These are just very plasticized PVC leads. So we've got shrouds. Yeah, it's got a long tip on there. So these are rated to, I say 10 amp there. You've got Cat 4 600 volt, Cat 3 1000 volt with the covers on. And I think these are probably a metre long, maybe 1.2 metres long, something like that. They look nice enough. So here is the calibration document which I downloaded from Keysight and obviously printed out. And it shows all the different measurements, so each range, the modes, the actual test frequencies, that sort of stuff, what the limits are, so lower limit, upper limit, and what actually resulted in, for example, and you know, right through. So you've got DC millivolts, DC volts, AC millivolts, AC volts, AC volts again, AC volts low pass, DC microamps, DC milliamps, DC amps, AC microamps, AC milliamps, AC amps, capacitance, resistance, conductance, diode measurement, duty cycle, frequency sensitivity, voltage measurement. So that's interesting. So that must be like a threshold for the sensitivity. Frequency counter, temperature, and that's the final summary of all the results being passed. It's probably going to get washed out because of the way I've got the camera set up, but yeah. So I've got all the calibrated values here, so I know exactly what it actually measured when I did the calibration, which is great. You know, it's always nice to have a starting point so you know exactly what you've got. I've looked through most of these calibration measurements, and this is actually, at least at the time of calibration, very, very accurate. This one's really good. Obviously you do get drift over time with the aging and that sort of stuff, but as it's been sitting in a box for months, you know, I don't know, 3 months and like, I think it's been made 3 months ago, so it's still relatively new, the calibration should still be pretty accurate, so it should be quite informative. So, rear panel here, tilting bale, nice enough, goes onto the back panel. So when you take the rubber bumper off, it's actually attached to the back still, so you don't have to have the bumper. Why you would want to take it off, I don't know, but in here you've got 2 panels, one's batteries, one's fuses, so fuses in the bottom panel, batteries in the upper panel. I had to take all this apart to get the batteries in. I've already installed them. And like I said, there's the interface there for the infrared sensor and the computer interface. We should probably turn this thing on. Right, let's power it up. So, 80 volts with low pass filter. Now obviously screen angle and my lighting are playing havoc here. I can actually see it myself without the camera, even at this, like I'm at this angle here, I can still read it. And the same from over here, I can still read it there. So screen angles and stuff are fine. The camera has a bit more issue with it because of lighting and reflection and stuff like that. So it looks a bit worse on camera than it is actually in reality. And I've still got the film on there. We'll do the screen peel later on. I'm not going to do it just yet. Give you something to look forward to. 80 volts, no worries. It's there and it's measuring temperature up the top here. So it's got lots of functions built into it, like secondary functions and options. The manual is quite extensive. I suggest if you're interested in one of these things, go and download the manual and read it, because it actually has a lot of information there and lots of features which aren't apparent just by looking at the meter. I might go into some of these myself and actually cover some video on that and actually try and go into some of these second functions and what have you. But it does a lot, so it's going to be a bit hard to sort of cover it all, especially in a reasonably timed video. I'll test these in the calibrator, so later on I'll go and hook this up to my calibrator over there and we'll see what values we're actually getting. Right now it's all floating because it's all just, you know, in the air. I'm picking up RF noise and all sorts of stuff. If I like short the probes together, it'll probably shut it up. There we go. Shorten the probes together basically kills it, so that's very sensitive. So those are both AC and they also do low pass filters. So if I come over here and if I did this one, that's the low pass filter option, which is like a little symbol comes up over there. You just kind of see low pass filter there. Right, that's what the orange means, the second functions. DC, nothing there right now, again floating slightly. If I do that second function, we've got AC instead. Or AC and DC, I think it is, something like that anyway. There you go, AC and DC there. Same for millivolts, same deal. Resistance and sounder. So, probe, short those together. These probably need to clean actually, these probes, they haven't been cleaned yet. I always give probes a clean because it makes them a little bit better behaviour. Let's just do that. Okay, so that's the probes cleaned up. Just touch them together. See it going through all the ranges, trying to find out where it is, and there we go. So it's a little bit slow to get there. And again release it and see how long it takes to get back up to open circuit. Well, let's do sounder. That's pretty fast. Now, let's check it properly. So this is the DMM continuity tester from Ian Johnston, who sent this to me for doing this kind of work. He saw me doing his multimeter reviews and thought he would make one of these. I mentioned this previously in other multimeter reviews where I discussed this unit. Anyway, plug it in. There we go. And there's the current settings. So this is supposed to be 1 millisecond response time. It's currently got 5 milliseconds. Let's turn it down. Still going. 11.3 is still going. Ah, there we go. About 0.16. Okay, let's increase the space time. Yeah, about 0.16 actually seemed like it's about it. Okay, that's pretty fast. I mean, it's advertised as being 1 millisecond. So it's way faster than what it said it's supposed to be. And that's fine, that's working alright. Can't complain about that. Now, it's not as fast as some other meters I've played with. It's still very fast. I mean, the fastest I've got can actually do it at 0.01. And that was this beastie here. That is super impressive. So even, you know, 0.1 is still very good. At least, obviously, that's for the sounder. Let's see what it takes to get the screen going. When do we see something on the screen? There you go. You kind of get it more reliably. About 200 milliseconds or so is when you start to see activity on the screen more reliably. Yeah, so kind of like a quarter of a second is where it likes to be to actually activate the bar graph and the display and the beeper. But the beeper's fast, which is good enough, I think. So let's look at diode mode. It does beep. It's a bit slow for liking though. Let's actually find something to check. We actually do have some diodes on here. It wasn't that bad. Yeah, it's probably a quarter second. It's like something low value. But yeah, that's not right, I suppose. It wasn't too slow. It just seems slower. That's okay. This is a shock key. Yeah, Okay. And diode test voltage, 3.3 volts. Also has a frequency option here as well, so you can push that so you get the frequency. I may look at that when I'm doing the calibrator stuff. We'll have a look at that then. You've got capacitance and temperature here, so here's a ball with some capacitors on it. Let's measure a capacitor. Obviously being in circuit means you may get some weird values. I don't know what we're going to get. .241 microfarad. What is it? 220 microfarad. Okay, not too far off. I mean, in circuit you're going to get some weirdness. Let's test some other ones. I've got some smaller ones over here. Let's do it this way. Again, in circuit you're going to potentially get weird values and slow charge time. 10 microfarad, that sounds right. And we've got this big cap here. Let's see what this does. .938 microfarad. It's probably 1000, is it? Yes, it is 1000. Okay, it's looking relatively accurate. I'll get my reference capacitors out in a minute. Over here we've got currents. It warns you about the leads. Right, so if you change into a current mode, it warns you about the leads being non-ports. Same for this one. So if I shove that in the amps jack, that'd be fine, okay? Because I've got nothing in that one, it's just warning you that it's in the wrong jack. If I change one of these other ones, it's also warning you that it's in the wrong jack. So it does actually warn you that you're going to potentially blow something up, which is nice. It also got a output here as well, so if you go to that, that uses this jack here. It will actually generate this information here. You can control this, it's adjustable. I haven't actually played with that yet, so I don't know if I'll show you, but it's got a waveform output. It's for 600 Hz at 50% duty cycle. Look at the voltages though. Maybe we'll play with that as well. So let's go back to DC volts. Here is my PDVS2 Mini, also from Ian Johnston. He sells these on his website, so interesting one. These references, definitely go and check that out. Can I set 0 volts? Let's do 1 volt. Here we go. 2. Interesting, look at that error there. Which one's wrong? See, I trust this thing really well. I have a really high confidence level in this particular unit because it's always proven to be accurate, and all things I've done cross checks on, it's been really reliable. So this is actually making me a little suspicious about the calibration on this one. I mean, you can see I'm below temperature, right? So I'm only 20 degrees right now. So maybe once it's been on for a bit longer and stuff like that, will settle down. But I would have thought this would be a little bit closer than that. This is a 60,000 count meter, by the way, as well. So 1 volt. 300 microvolts out. I don't know. Is it better? Okay. Let's try 100 millivolts. Let's go to DC millivolts. There we go. So in this mode it's reading 2 counts down, so that's like 20 microvolts down, but here it's reading 100 microvolts up. So I think it is calibration thing on here. I don't think it's this. Pretty confident of that. So it's interesting that the actual specs said it was better than that. In fact, let me check this. Right now I'm generating 600 millivolts and we're getting almost exactly 600 in here. It's got a bit of a rounding thing going on there. Again, my temperature's not perfect. It's not quite the temperature. But on the calibration report it should be 600.01. So it's within 1 count of the calibration, so that's looking good. So if I go down to 60 instead, which is one of the other calibration points, 60 millivolts, measured value was exactly 60 apparently. We're getting 59.98. It's interesting the way the actual rounding on here, like this is showing 3 decimal places in this range and this isn't. It's just showing 60. Okay, interesting, but it's still pretty damn close. 20 microvolts out. Right, let's try a different voltage. Let's do 6 volts. And according to the calibration report, it is doing 6.0007. And we are 6.0089. Okay, so that's still pretty good. That's very much agreeing with this, really. Again, temperature's not quite perfect. So I can check this in a lot more detail once I go to the calibrator, because we can check every voltage calibration point from AC and DC and just verify that what I'm getting here matches what Keysight said they got. Of course, Keysight's equipment's going to be better than what I've got here by far, and it'll also be currently calibrated, whereas my stuff isn't. It's just good to do a cross check and just see what we actually get, see if anything looks completely out of whack, because it can happen. Right, let's check capacitance mode properly. Here's my standard capacitors. I've got 200 picofarad right here. Let's plug this straight in. What did this around? Getting 207. Okay, it's reading slightly high. Let's try my other ones. So this one's a 1 nanofarad. 1.056. Interesting. Okay. What does my calibration report here say? Because these are definitely measuring higher than I thought they should be. The smallest calibration value it's got on here is 10 nanofarad. Okay. And that said 10.01. Well, I actually have a 20 nanofarad here. So let's try this. 20 nanofarad. 20.1. Interesting. Now, it does some notes on here about frequency and stuff like that, which does affect the readings, obviously, because the capacitive makes the reactive, but 0.1 up? Not sure about that. Okay. That's 10 times worse error than it says on the data sheet for the spec. The upper limit is 10.105 for the spec, so it's just in. It's the 1 microfarad. 1.001, that's looking pretty good. And according to the calibration, 1.0001 is what it's giving it during calibration, so again that's an order of magnitude out compared to what the calibration data is. My own measurements have done confirmations of basically what these are, but yeah, 1.005 at 10 kilohertz and exactly 1 microfarad at 100 hertz. So I suppose it depends on what this frequency is as well. But to put this in perspective, the upper limit for the spec is 1.01. So it's another order of magnitude higher than this. So that's actually pretty good. So this is seemingly a 10 nanofarad range based on the scale here. In fact, we're only populating a very small amount of scale. If I go to here, let's change to 100 nanofarad range. Okay. I need more standard capacitors. So let's measure the frequencies with this thing. I'm just re-recording this part of the video because I didn't like how the first one came out, so I've got a bit of a better understanding of this now, so I'm going to cover that in here. So you go to this indicator here, you push that to change the frequency, and I'm currently generating a 10 kilohertz signal at 10 millivolts using my RF signal generator. 10 millivolts, and you can see it just fine. That's alright now. So let's actually just try some other stuff. Let's try 5 millivolts, let's halve it down, still see it. Let's do 50 kilohertz. Yep, you can still see that at 10 millivolts. 100 kilohertz. You can still see that. Great. 500. No, hasn't updated. So let's give it some more power. Let's go 50 millivolts. There we go. Let's do 1 megahertz. Can't see it. Let's increase the RF level a little bit. 200 millivolts. There we go, now you can see it. Alright, that's towards the top of that range, so I need to change ranges. There we go, 1 megahertz on that range. It is, say, slightly off frequency there, it's not perfect. It's true 5 megahertz. You can see that. 10 megahertz. Yep. 15. Yep. 20. Yep. 25. Yep. 30. Yep. Do that, and that's at 200 millivolts. 35. No, that's unsurprising. Now, what I've actually seen in the past day or two is Joe Smith, who does a lot of Multimeter reviews. He's also just got one of these, and he's reviewing it now. I think he's only just got it anyway, but he's doing reviews on it now, and he's found the same thing with the frequencies being weird. You can't measure above about 31 megahertz. So I go 31, and I increase my RF level a little bit. Let's go to, say, 300 millivolts. Is that enough? No. 500. No. 800. Nah, so 31 megahertz right now, I can't actually see it. So back down to 30 megahertz again. Can't do it. Okay, I have to drop the level down back to 100 millivolts. 200 millivolts, yeah, okay. So 30 megahertz, even that is being a little bit glitchy. So 30 is like the very top end of what this thing can actually do. Now interestingly, it says it's a 100 megahertz range. But also interestingly, in the calibration data for this thing, it only has a calibration point, or at least a check point of the calibration, of 1 megahertz and 20 megahertz. So I was actually initially thinking 20 megahertz is the top end of this thing, but it shows as a 100 megahertz range. In the specs it shows it up to 100 megahertz, but no accuracy guarantees above 20 megahertz. So it's like above 20 megahertz, it's like a free-for-all, you get what you get. But it seems like 30 is the very top end, so I think this statement of 100 megahertz range is not good, because I cannot get a frequency basically above this, and neither could Joe. Although it says 100 megahertz, forget that. 30 megahertz, absolute top, and even then you can see it's only barely doing it. So if I go to say 28 megahertz instead, there we go, that's handling that alright. And that's 200 millivolts. Let's go down to 100 millivolts. Still fine. 50, yeah, still there. So yeah, like 28 megahertz, call that the top end cut off. Don't expect anything better than that. Which is interesting, because you know it's like there's a disjoint between this and what the specs say it should be able to do, and it's across two different meters. I mean, maybe it's because of part shortages, maybe the recent batches have got different parts in them, like substitute parts, maybe those parts aren't up to standard. I don't know, it's possible. Maybe these are compromised in some way. I'm speculating, obviously, I don't know. I just find it weird that it'll say 100 megahertz in the spec with no guarantees of accuracy when it can't read above 30. You'll think they'll just say the cut off is 30 megahertz and that's it, and yeah. But anyway, another interesting point about this is that when I look at the calibration manual, because you can get the calibration manual for this, tells you how to do a calibration on it, and verification. The verification points are 1 megahertz, 20 megahertz, as I said before, as it is on the calibration report. But there's no actual information in the calibration manual on how to calibrate frequency. It's completely absent. There is no mention at all of how to calibrate frequency, which I find very interesting. It tells you how to do everything else. Frequency is not there. I mean, to me, this is like a minor issue anyway, really. I mean, if you're trying to measure frequencies, get a frequency counter. It's a multimeter. I mean, yes, it's going to be helpful to if something's there. Absolute accuracy is not going to be there anyway. It's going to be close, but it's going to give you ballpark figures. To me, frequency counters and multimeters is more of a gimmicky thing. I mean, up to a point, it's useful. You know, you're trying to measure AC stuff, you know, AC waveforms, and trying to make sure that you've got an AC frequency there. If you're doing like a variable speed drive or something like that, then it's helpful for that. But otherwise, I don't really see it being useful in RF frequencies, to be honest. Maybe there are use cases, but I'd say in those cases, get a frequency counter. So something it does have is nulling. It does have that feature on it, as well as min-max and things like that, and logging. You can also change frequencies. You can see it changes mode right now on AC. I actually went to frequency mode, and you also tell time from that too. Duty cycle and frequency. You have to go back, just do that. Backlighting. It's got backlight on it. It's got adjustable backlight time. I think by default it's 15 seconds, but that is adjustable in the settings, which I haven't got into and played with yet, but that's something we'll be doing. I think it'd be put up to 90 seconds, I think the maximum was, something like that. There you go, it's gone off again. I personally prefer a longer backlight time, because if you're using the backlight, it's because you're trying to see the display, and in that case you probably don't care too much about battery life, you just want to see what you're doing. So I'd actually incline to just to put that value up all the way, because after 90 seconds it'll turn off, and okay. But you know, it's less likely to then happen whilst you're trying to make a reading. So you've got manual range here, so you've got 6 volts sitting there, 60, 600 and 1000. But that's have dual functions as well. You've got frequency available in there as well. This has got lots of second functions. I think it's going to be hard for me to go through all of them and cover them all. Anyway, hold that down to the older range. So also got voltage sensing, dual display, as I said. Peak measurement. It's got logging as well, and you can also view logs. Those are things I haven't played with. Also got holding, and also got, this is a two-way arrow. I haven't played with this yet either. So trigger hold, and it will actually hold it on display to get another trigger point. And turn it back off again. So That means if you're trying to do a measurement, you can't see what the meter's doing, you can't watch it. You can turn this on, it will trigger, and when it gets stable reading, it will hold that on display until the next stable reading. Now it also has voltage sensing, high voltage sensing, which is what this one is. Actually, I should show you that, shouldn't I? I don't think it matters which mode you're on. Push that down. Got high sense, and it does actually have, is it low sense as well? Is it on range? There we go, range. High and low sense. So if you have a mains cable nearby, it will detect that and warn you. Let's actually get a mains cable nearby. Right, so you can see that little LED come up there as well. Take it away again. A bit closer. About there, right. Kind of out of shot. That sort of distance. Better high sensing. It's actually about the same distance. That's interesting. Anyway, so loads of functions in the back end of this thing. Alright, screen peel time. You ready for this? Oh, messed it up. That is really stuck. Oh man. Okay. Oh yeah. Something else this has on it, you may notice it's got an extra port here for remote. RMT for remote. So you can actually get a probe which has got like a button on it or something, and you can actually plug that into here, and you can then do like a remote action on the meter. I don't know much about that, but interesting function. If it sounds like something you might be interested in, maybe check it out. You also notice down here it says IP67 rating. That's pretty impressive. IP67. I'll put a chart up which shows what they actually mean. 6 and 7. One is for dust, one is for moisture. So this is the manual, or at least the part of the manual. I'm going to show you this. This is the making measurement section, which tells you all the things you can measure. This is stuff you can actually do with this meter. If you want to see this in more detail, then download the manual. I'm not going to cover each one of these little things. I've shown you some of it already. Multimeter features. Here's some more information about what you can do. And as I mentioned, it does do logging. And that's not something I've played with yet or even tried using, so I can't really demonstrate that, but it does do logging, do manual logging and auto logging, which does it after a period of time, so every however many seconds it will grab a capture and log that. So that's also really handy, and obviously. So what I actually want to cover is the setup options. So this is the setup menu stuff. So in here you can configure the meter to do different things, different preferences and how you want to use it. And these are the different options in here, in this list. Things you can do. How to get into the setup menu first, that's the first thing you'll do is get in there. All you basically do is hold the shift key down, turn the power onto the meter by turning the main knob, and that will then drop into the setup menu. Then you can scroll through the menus and find which setting you want to change. And basically you do have cursor options, so the hold left and right is left and right, and you also have the null and the dual button, or the backlight button, whichever way you want to look at it, null and backlight. They're the up and down buttons, so you can use those three buttons to basically navigate. And then you got the log/hertz save button that actually saves the setting once you've selected one, or if you want to exit without changing anything, you can just click the escape button. So this is what this is explaining as I just described. So these are the things you can do. Auto hold. So we've got options here with D and E. D means disabled and E means enabled, and default is disabled for this function for auto holding. Also got this mode time, smooth mode, and it's also disabled. Auto off time, which is enabled, which is 15 minutes. So you can go from 1 to 99 minutes with that. So if you want to reduce that to say 10 minutes or 5 minutes if you don't use it very often maybe, then you may want to do that to save your batteries. Then you've got backlight, which is one I want to change. This is currently set to 15 seconds. I want to increase this to be the maximum, probably 99 seconds. Data logging option. Default is manual logging, right? So hand, auto and trigger. So you can figure this once you actually understand how logging works. So I haven't played with this myself yet, so I can't tell you. It's also got login duration, which interestingly has got the same prompt on screen as this one up here. That looks the same to me. Am I missing something? Those look like the same indicators. Anyway, so this is setting the timing for the logging. dB reference, so you can actually do dBms, and the reference is based on 50 ohms, but you can change it between 1 ohm and 10k. And coupling, J or K type thermocouples for the temperature measurements. Next page, units, centigrade, Fahrenheit, or Celsius, you want to call it that. Default Celsius. Beep frequency, you can change that if you want, or you can turn it off. So when you've got the beep going off, it'll, you can change which tone you want. Maybe, I don't know why there's so many tones, so I'm just surprised by that. But maybe if you've got multiple people working in the same place with the same meters, you want different tones so you don't get mixed up with whose meter's beeping. I don't know, maybe. This is an interesting one. I'll play with this one. You can set the beep or melody or off. So when you turn it on, it does that beep when you turn it on. I'm likely to turn it off, but it's got a melody. I might turn it on just to see what that does. I'm likely to turn that sound off though. I don't need to know when I turn it on because I'm turning it on. Continuity type, so short, open or tone. I might play with that as well to see what it does. So it will beep on short right now, which is default. I mean, might mean it beeps on open instead. Or tone, maybe it means it changes pitch as you're actually doing a different test. So multimeter's alert type to beeper, flashing red, both at once or none. So the default is both at once. Battery, primary or secondary, which means like a alkaline kind of battery or rechargeable. Reset to the factory defaults. Remote probe button, so you can configure it to do different functions with the remote probe. Again, I don't have that, so I can't demonstrate or really talk about that too much. Display count, so you've got high resolution and low resolution, which means you can get faster readings if you change it to low resolution. Default is high res, which is 5 digits or 4.5 digits. But you can go to a lower resolution, which gives you faster readings. And you've also got the same thing here, multimeter display refresh rate, 5 or 40 times a second. And I believe if you've got it set to 40 times a second, it automatically drops down to the lower resolution. I believe that's the case. I haven't tried that. And other settings here on the next page. Input impedance. So in the millivolt range, you can have either 10 meg or basically 1 gig of input impedance. So some other multimeters actually do this, like my Siglent bench multimeter. This actually does this as well, so I can select which it does. I don't think any of my other meters do that. I think they're all basically 10 meg ohm by default. But this may be handy if you don't want to load down circuits, stuff like that, if you're trying to take small measurements, and that could be a really handy feature. No, I found it useful in the past. Low pass filter for DC on current measurement, default is off. It means it smooths out the reading a little bit. You may not want that if you've got AC writing on it. You don't want to hide that, you want to see it. And the same thing for the AC as well. Default is off. But you can manually set those anyway. You can turn those on manually. That's that stuff. Let's play with the menus. Also, don't forget to click like and subscribe if you're liking the video, or if you want to see more review videos. Right, let's try going to the setup menu. So you're supposed to push this button here, turn it on. So auto hold. We don't want that particular one. Don't want that one. Auto off. Backlight 15 seconds. Right, I want to change this one. I do want it enabled. But I want to increase it to the maximum. Oh, I could have gone down with it actually. It wraps around, that's nice. So 99 is the maximum. And save. So, next setting. Hand, that's the triggering stuff. dB reference, coupling, beep. That's the frequency of the beep set to. Sound is beep when you turn it on. Right, so what I'm going to do is just do this again. Just exit the menu. I'll go back into this. See that beeper did then? So, let's go back in. I want to see what that actually ends up being. Oh, sound, this one here. So, we want melody. I guess that means melody. Alright, let's try that. Okay. I think I'll turn it off. Save. Yeah, okay, anything else we need to do in here? Type short we want that, don't we? Horn, battery primary, reset no. Don't know what that was. Display high resolution. Display update is 5 times a second, which is fine because I think, like I said, if I go to 40 times a second I believe the resolution drops. Let's find out. So yeah, now we've got less digits going on here. We don't have the primary digit there. Yeah, but look at the update rate, that's pretty nice. Anyway, yeah, I think I want to keep it as high resolution. More digits is better. So you'll find it again. That's the update rate. So back to 5. Okay, what else is there? Input 10 megohm. I'm going to leave it at that. Low pass filters are off. That's it. Okay, let's get out. That's the menu. More digits. So now we need to go over to the calibrator and actually check this thing out. Check all the things like DC volts, AC volts, DC current, AC current, and resistance. Oh, and frequency. We can check all those over at the calibrator. So let's go do that. So, to the calibrator. This is Future Scott here. I'm just editing this video, as you can see, and I've decided that it's getting a bit long. So I'm actually going to do is split this into 2 halves. So tomorrow I'm going to publish the second half, which is where I put this thing through its paces on the calibrator. As you can see here, we've got some interesting things to look at. Let's actually worry about that tomorrow. This is the video for today. Make sure you come back tomorrow, watch the second half if you're interested in the calibrator results. So thank you very much, Daniel, for sending this to me from Keysight. Much appreciated. Great little multimeter to have around, although it's not that little. I was tempted to do a teardown on this, but this video's got long enough, so I'm not going to do a teardown because this video's already way too long. It's got functions and stuff which I haven't covered, such as the computer interface and the logging and things like that. I may do a follow-up video with this if there's demand, that people actually want to see me trying the logging out or trying to get the computer interface working and doing a teardown. Maybe I'll do a part 2 video, just do a follow-up to this, just to complete it. So again, thank you much, Daniel. Much appreciated. Don't forget to click like and subscribe if you like this kind of videos. I'll catch you later. Bye.